Hi, today my name is Gerard Naranjan. So today I'm gonna explain about nickel aluminide. So what actually is nickel aluminide? Nickel aluminide is a metal that has a nickel as one of its primary elements. Also, some type of nickel alloys are referred to as superalloys, which of the superior oxidation and creep resistance that allow them to be used at a temperature of more than half the melting points. Some of the nickel aluminide, so known as Econia, Monet, and Hastelloy. This one is after the advancement of the nickel aluminide itself. So for NIAL, the common usage was usually been seen in special high temperature application like coating on blade in gas turbine and jet engines. For the properties of NIAL, first one is the corrosion resistant. Nickel alloy have excellent resistance to corrosion and oxidation, which making them ideal for use in the harsh environments. So for the second properties was the high strength. These nickel alloys also have very high strength, which they are very beneficial when the high strength and toughness are needed to elevated temperature. In terms of the heat resistance of the properties, it can withstand up to 980 degrees. This is for the cases of the Econel 718, which is the advanced of nickel aluminide. So for nickel alloys, it have a very high ductility and such a very tough materials, which is able to withstand impact without breaking suddenly. So for the advantage of the NIAL, first of it is the corrosion resistance, second is the high strength, third is the soft magnetic properties, fourth is the heat resistant, fifth is the low thermal expansions. All these advantage of NIAL is it has become the choice why it was used in a very tough and challenging environment such as the gas turbine and the jet parts. As of the corrosion resistance is NIL didn't allow very fast corrosion because of it high resistance to the corrosion and oxidation. Uh, Also, the high strength also make it suitable for critical components and applications, such as for the blade coatings. As so for the submagnetic properties, some nickel alloys exhibit excellent submagnetic properties with low corrosivity. This means they can be easily magnetized and demagnetized. So here we can see the mechanical properties for the NIL. Tensile strength, the ultimate is 45 megapascal. For the maximum is 317 megapascal. For the tensile strength is 59 megapascal and negation effect is 30%. For the modulus of elasticity is 207 gigapascal. For the shear modulus is 76 gigapascal. So from here we can see that NIL is a very good materials that can be used in a very challenging and extreme conditions and environments.
Hi, my name is Zulkarnain Zakaria. So I will be presenting on the phase diagram for material nickel aluminide. Diagram shown left the composition of nickel, to the right is aluminium. For example, we'll be taking eutectic phase at composition of 28% of aluminium. At this point, the eutectoid temperature is 1362 Celsius. Therefore, above the eutectic temperature, there will be a single phase liquid, and at temperature 1362 Celsius, perlite begin to with lamellar form on microstructure. Whenever the temperature drop less than 1362 Celsius, the aluminium nickel tree will occur in the form of perlite. So next is diagram shown cooling curve for nickel aluminum component. The solidification begins at temperature 646 Celsius and the solidification complete at temperature 642 Celsius.
Hi, my name is Amir Izzat, and now I will present how to improve the hardness of alloy. First, we have heat treatment, which is quenching and tempering. By using this method, the alloy will be heated and cool it quickly, then reheat it to make it hard but less brittle. Next, work hardening. Work hardening is the deforming method. We will bend or shape the alloy at lowest temperature to make it harder. Next, adding elements, which is the method that we will mix in elements like carbon or nickel to increase the hardness of alloy. By deforming at room temperature, shape the alloy at room temperature to increase the hardness. Mixing elements. Mixing elements is the method that will add the elements that distort the crystal structure, making it harder for the alloy to deform. And the last one is grain refinement. Reducing the grain size will make the grain smaller to increase the hardness. Each method changes the alloy internal structure to improve its hardness for specific application.
As a conclusion, nickel aluminide is an intermetallic compound known for its unique combination of properties, which make it a promising material for high temperature application. The exceptional for oxidation resistance, superior strength and stability, elevated temperatures, along with the low densities, provide a significant advantage in various industrial sectors. So we usually will see everywhere that needs a very good materials that can co-op with a high and challenges environment. So despite its remarkable attributes, nickel aluminide also faces a challenge in terms of brittleness at lower temperature and difficulties in processing and fabrication. However, the ongoing research and advancement in material science have been progressively addressing this issue, such as through alloying addition and novel manufacturing technique, which will enhance its mechanical properties and workability. So that is all about the nickel aluminide. So thank you for listening and hope you guys enjoy our videos. Thank you.